friends. Hello, friends. 1, 2, 3. Excellent. I cannot see you, but I assume that you are there. How are you? How was the conference? Nice. Excellent. Perfect. I loved it as well, and it's an honor to be here. So if you don't like this, don't take it on Spring.io in general. Just write angry tweets at me personally. But I hope we're going to do fine. We're going to do fine. So this is the last session. I was very surprised when I found it out in the schedule. And I thought initially that I'm going to give you the API, the concepts. I'm going to show you how to do things. And then I'm going to teach you things. And then I figured out that we were going to be very tired here at the end of this. And so I decided that instead of that, we're going to just talk about things that we love. Right? We're going to just try to make memories about how things can be in our life, in our software development. So talking about things we love, how many of you love Spring Boot and, say, the Spring Initializer? How many of you have seen Josh talking about how production is the best thing ever? Disagree. Continuous integration is the best thing ever because there is no responsibility. Right. So because when you start your application, you are all very happy about that you are starting from the clean sheet of paper, there is nothing, there are no legacy code that you need to maintain. You're going to do it right this time, and then you're going to write the code, and it's going to be perfect. And also, at the same time, you kind of somewhere in the background of your mind, you're like, I have to write tests. And, well, maybe it's not you, maybe it's somebody else on your team or your manager. And surprisingly, very, very many people don't like to write tests. How many of you like tests? How many of you like the reliability that they allow you to refactor freely, and how you are know when you deploy stuff in production that everything works because you have great test suites? How many of you love writing tests? Debugging flaky tests in CI? It's pain. It's pain. So there was a recent report and a survey of the ecosystem by the folks at the Retool, which is a sort of a they do this backend system for low-code environment where you can just drag and drop apps. Kind of cool, but that's not strictly relevant what they do. But the report, what they asked a ton of engineers what they like, what their daily process looks like, what they do and not do. And one of the questions was to arrange the things that people would wish they spent less time on. And they asked, and they separated the respondents into two groups. One of the individual contributors, the normal engineers who write code, well, day to day, right? And then the top entry was, we would wish we spent less time testing things because apparently that takes so much time. And what is very surprising, that people who are at more senior positions, maybe team leads and whatnot, they also said the same thing. Testing changes takes too much time. What we answered to them, they maybe don't know how to do this properly, right? Just kidding. It does take a lot of time. It does take a lot of discipline. So today I'm going to talk a little bit about how maybe you can simplify your testing infrastructure with test containers for your Spring Boot applications. And we're going to look at some, well, how you can also use the same thing for your local development to simplify things. Because it's all that great. And in the end, maybe you will love spending time writing tests. Back in the day, where computers were large, well, medium-sized, and the phones had buttons, and Instagram and Uber were young companies, we kind of, as a community, as the ecosystem, we had an idea how we should test our applications. We would organize our tests in different sort of layers by how the tests look and how they feel when we are creating them and running them. And we would know that we have a ton of unit tests. They will be fast. They will be testing isolated components of the code, maybe a method, maybe just a few method calls. And then there will be a lot of them. And then we would have a fewer integration tests, which would test the systems with different components in play, right? So maybe a couple of components in the system, maybe some external systems like databases. And then even fewer tests because of the maintenance cost and how hard it is to run, wait for, and maintain, end-to-end tests, which we call sort of integrated tests, where the tests run in the environments that are similar to the production environment. So you have the whole cloud for the production, and then you replicate the same environment, and you run tests in it, and that would be end-to-end tests. And because of the complexity for maintaining those, there will be fewer of those because it's awkward to run that on every commit. It's awkward to rely on them in your day-to-day development. So that was in the past. And then recently, when everyone kind of sort of migrated to microservices and the applications became smaller, not necessarily faster, but smaller, we figured out, and this is a collective we again, that maybe having so many unit tests doesn't actually bring so much benefit, because the logic of our systems isn't exactly in the, well, code details. We don't do lots of business logic in code that much, but very often our system composed of different components, and they just call each other over the network or talk through, like, I don't know, send data to the message brokers, receive that, and just do a little bit of computation and then pass the data back to the next component in the system. And in such environment, it doesn't make sense to have a lot of unit tests or implementation detail tests, because there is not a lot of implementation to test. But what is more important is to have the understanding how your component, how your system, how your service behaves in a larger group of services. So what we understood, and there are a number of like people who came up with the different definitions or the shapes of the how we should organize the tests. Like it could be the honeycomb, which was described in the Spotify blog post by the Spotify engineering team, how they test their microservices, and there were like some trophy-like systems where the different components of different size and others. But the main takeaway in the last, I don't know, now maybe 4 or 5 years, was that maybe we should rethink what kind of tests we rely on, with the notion that maybe integration tests could become more prominent in our test suites. My name is Oleg Šelajev, and I work for the company called Atomic Jar, which is was created by the maintainers of the Testcontainers Java library. And we're going to talk about integration tests now. So what I mean when I say integration tests, that could be the bulk of our test suites, I mean that we could have the system composed of different services, and we would test it in isolation. We would not try to deploy the whole thing with all the colored blocks in there, because it's hard to, well, we might not have the resources locally, we might not have the ability to spin that environment quickly enough, so it could be awkward. But what we're going to do, we're going to take our microservice or our application, and we're going to create the environment around it for one step further. So we're going to have those actual real dependencies that we want to, like service dependencies. And some of them could be stock software like databases or message workers or Elasticsearch, or if we need a Kubernetes cluster, that could be our Kubernetes cluster that we test against. But it would be the real thing. Or in case of the API, if this is the third-party API, either like completely third-party or something that other teams maintain, we're going to mock them on the service layer, and we're going to just rely on the next stage on the contract testing to verify the correctness of the mock. But we're going to work with the actual services that we somehow can verify the correctness of. So we're not going to just mock anything within the process. And we're going to create this slice of environment, and it's going to give us two very important things. It's going to create for us the exact border so we know what kind of environment we need and we have. So we will never need to like redeploy the whole Uber infrastructure because we just change our one small microservice, but it just transitively depends on the whole universe. We always know exactly the border of how much we need to deploy to test things. And the second thing is all of the components there are correct and verified. So the issues, if we test, it discovers any issues, that's on us, that's on our application, that's on that red square that we're actually actively developing right now, which means that we have the full power to actually fix those. Because if you have a complex environment and something breaks, you never know whether this is your fault or not. And then you absolutely, I'm sure that at least half of us would be inclined to say that it's not our fault. How many of you have found bugs in the JIT compiler? How many of you have thought that you found bugs in the JIT compiler? Okay, not many. Very good. Usually people think that other people cannot write proper code, so they blame everyone else. Not a good, very healthy practice, but that's how it is. So we're gonna work with slices of the environments. And we're going to use technologies that are common and widespread, and we're going to put them in use to simplify the creation of the tests and simplify deployments of those environments. And for the main technology, the sort of the giant on the shoulders of which we're going to base our test use will be Docker. As the, not even exactly as a product, but as the technology, as the sort of cross-platform solution that allows us to do very interesting things. And Docker gives us two main use cases, very good, very big kind of sort of functional things that Docker allows us to do. And those are, of course, the first one, it allows us to give our software to people to run. Because then they can like very naturally run the software as if they're actually using our machine. And the second use case for Docker is the opposite of that. Is just it allows us to run other people's software without actually going into details how to actually run it. So we can run software in isolation. And this is exactly what we're going to use. We're going to use Docker to run whatever software we want. And we're going to use that to run it in our integration tests. And Docker is great. Docker provides a very large number of things that we want from the solution like that. It gives us the processes isolation. It gives us the file system and network isolation. It allows us to control the environment where we want to start our software, like say a database. We can give it enough resources, and then where we can limit it. So there is a flexibility, and it also everything works in Docker, which is great. We can run all technologies, including I don't know the headless browsers for our if you want like have UI tests and everything. And it gives us the common interface to how to run things, which is great for automation. Unfortunately, if we look at the integration tests and tests in general, this is a very stressful sort of use case. And it's stressful in the sense it stresses every component in the system by default. We want to run our tests in a way that it actually verifies that our system works correctly or handles errors correctly in the corner cases where it's pushed to the limits. So that includes, I don't know, the broken data model or the network outages or, I don't know. So for integration tests, for proper test suites, we'll have to have a lot of flexibility in creating those environments and those scenarios. Unfortunately, the stock options for controlling Docker containers is not exactly that flexible enough for us. For example, how many of you know how to run Kafka in container? That many? Not many. So, well, you do a little bit like this, and then you run it, and this is exactly what we don't want to do. What we want to do, we want to have a simpler approach to that, and that is where Testcontainers enters the picture. Testcontainers is a collection of libraries, that exist in different languages, most popular programming languages, Java, .NET, Node.js, Go, Python, and so on. And it integrates on one hand with Docker to provide the configuration and the programmatic API in your favorite programming language to create and manage those services in Docker containers. And on the other hand, it integrates with your testing and application frameworks. It all started more than 7 years ago with Testcontainers Java. And this is a very long period of time, because Docker exists for like 8 years, so it might not seem like that much, especially in the Java ecosystem age and number of years, but it was created very, very quickly after Docker was created. And what it does, it uses the Docker API, so it doesn't integrate with your command line Docker utility or anything. It does the calls, and it integrates with Spring JUnit, and it simplifies your integration tests by providing you means to use Docker effectively for the environments. And what I mean by what it simplifies, what it gives you, is very often when you try to create a solution to something, we look at the problem, what we're trying to solve, and then we come up with a solution, and we're happy this works. But very often we are just replacing a hard problem with a hard solution, and that is not what we want to do. Because, well, if it's equally hard to solve something with a tool, then it's not good. And it's also very often the other kind of edge of the spectrum is the same. What you want to have, a tool, and ideally a very good tool with a good experience, is that it makes hard problems easy and easy problems absolutely trivial, so you don't even think about that. And I think Test Containers hits a very sweet spot between the things there. So what it does for you, it works with your Docker environment, and it could be any Docker compatible environment that you can run. It might be your Docker desktop, or it might be a remote Docker, or if it can talk to the Docker API, it can work with it. And it does a number of checks to see and verify whether your application and your test can run nicely, and then it fails quickly if it doesn't, which is great because it's good for reliability. It also does the automatic cleanup, which is very, very important for tests, because you never want any lingering resources being somewhere after the test run, both in your local machine or in CI, and Testcontainers takes care of that. And then Testcontainers also does quite a bit of, with the experience that we have in the integration tests, we also take quite a bit of kind of know-how how to run integration tests. For example, we do a lot of port randomization because we want to avoid the port conflicts if you run multiple services. We allow you a flexible way to parallelize situations and your tests, and also to create data and the configuration for individual services. So it's pretty great, and you should look into that. A recent ThoughtWorks technology rater put us into the adopt category, but even better, what's said about that Test Containers they think could be a default option for creating reliable environments for tests, which is a great thing to hear, because the reliability is exactly what you want in your tests. So, how many of you haven't used Test Containers before? Like, am I even? Okay, how many of you use Test Containers all the time? How many of you just are sleeping here? Okay, if you, right, okay. Right, so if you use that in Java and love it in Java, you can always also go and tell your colleagues that they also can use Test Containers in their other languages. I know that the other most popular ones, I think, are Go and Node.js, and I don't know about the rest, but those are committed by the community, so people kind of sort of saw the benefits of the approach and created this. Right, so I'm going to show you now a few tests for people who don't know what test containers are about. I'm going to introduce you to some API for the test containers concepts, and then we can see how we can apply it to different use cases. This will be our sample application, which is a one microservice, and it deals with ratings for the conference sessions, and it stores the sessions, the conference sessions, in a database. We're going to use Postgres. The two different components of the same application talk to each other via Kafka, because that's how we develop things nowadays. And then we also use Redis as an additional data store. It's a little bit over-engineered for such a simple application, but what's great about that is that there are many service dependencies that we can work with and show how to use test containers. And the whole model is very simple. It's rating that just takes the talk ID and the integer value, and that's the whole system that you need to understand. Right, let's look at that. This is a very simple application. It's a Spring Boot application. It would be awkward if it wouldn't be Spring, right? Would be a little bit awkward. And we have the rating view controller, which is exactly the one thing that we're going to touch from the internet. And it has two beans there: the talks repository that talks to the database, and the ratings repository that talks to Redis. And there is supposed to be also a Kafka thing, right? Kafka template here as well, right? So this is the whole application. I cannot even run this application because I don't have my database anywhere, but I do have tests. So here I have a very simple test, and I have the abstraction level there, and a collection of test cases here. Does the context loads? This is a very useful test that checks that the Spring application actually wires together. We talk to the actuator endpoint to see whether it returns to 100, and we actually use the application as intended by hitting it with the HTTP queries using the rest assured library, which is actually a pretty great choice for creating HTTP requests in the tests. So we just say, like, oh, let's hit the ratings with the new rating for Ola Spring IO with value of 5, and then wait until that rating propagates through Kafka and comes back to us. And then we do that a bunch of times again. And so we have a test suite. So I can run this test suite, of course, and I can run this individual test here as well. While it runs, while it thinks a little bit, we can look at the abstract integration test here. This is where our test configuration sits. We run it as a Spring Boot test, and we don't look at that yet. It was very fast. Right? We run it on a random port. We inject this random port back into our application to know the configuration, and we also set up the rest assured request specification here in the superclass, just because it's easier than to use in our tests. But this is just a boilerplate that is not strictly relevant to our application. So we run this basic context load test, and it doesn't work. Our Spring application is broken. How could it be? How could it be? Because our application requires those service dependencies, the database, Redis, Kafka, and we have none of that. We have literally none of that. So we're gonna use test containers now, and we're gonna, well, alleviate that. We're gonna create that. So what I need to do, I need to add the dependencies there. Test containers to the Java library, so I go to Maven and I find the modules that I need, and we're gonna use the test containers, the core, and the integration with JUnit Jupyter for the lifecycle management. And we're gonna have a couple of modules because we know we're gonna use Postgres and Kafka. We bring those modules, and those modules bring us abstractions that simplify our environment creation even further. And then we're gonna go to this abstract integration test, and we're gonna create first, what should we create? We should create maybe the database, because here our test just fails because it fails. Why it fails? I think because that cannot create the database. Cannot create the database, right? Can it create the database? No, it's supposed to, right? JDBC fails, right? It cannot create the database, so it doesn't work together. So what I can do, what I can do with test containers now, I have a number of abstractions. The main one being the generic container. The generic container abstraction allows us to create the containers that we want. So we can do whatever, and we can say like new generic container, and we can give any Docker image name that we want. So for example, I don't know, Postgres, and then we say the version, whatever the tag is. And this would be our generic container. What? Generic container. We need to do this for the thing, say database. And this is our generic container. What it represents the container that we're going to run with some application. So here we're going to run the Postgres. What's cool about this is that it provides you with the API. So to do anything that you want to do with the Docker container. So if you normally would do something like, how do you run Docker? You do Docker run, and then you do the ports publishing, say 8080 for your application or something, right? And then you say image name. This is exactly what we create. So we pass the image name, and then we have the lifecycle methods to do. So we can say start and stop. And we also have all the configurations. So we can, for example, this is our generic container. We can publish the ports. We can say that we want this, this container expose ports if we wish, because we know that the database, we're going to hit the database through the API, right? And then we're going to say with exposed ports and whatever the Postgres port is on that we need to do, and then we say start, for example, right? And this is the very basic API. It wants an exception here somewhere, but so we're not going to do exactly this. But this is just the basic abstraction that I want you to know. And everything that you do with Docker, you can do this. You can configure what files you need to copy to the container, what are the environment variables that you want to specify for this image, what are the networks if you want to build complex topologies, execute commands, copy files in, copy files from, read the logs, the whole thing. But it's also, you don't need to know anything about Docker because you just type dot in your IDE, and the IDE suggests you everything you can do, which is great. And also, you don't need to touch anything, any YAML, which is a win in my book. Right, so we're going to run the Postgres. Databases are a special case, so I'm not going to even run Postgres like that manually. I'm going to use a special integration with JDBC. And I'm going to just specify the property here with the database URL. So I'm going to do Spring data source URL. And usually this is where you give the JDBC URL to the thing, right? So we're going to do, what's that? JDBC, and then you do the URL. I'm going to instrument it with the Testcontainers prefix. So when Spring will try to find the driver for my database, it will be like, ooh, Testcontainers driver, who registered that? And the Testcontainers library registered that. So it will go to the driver and say like, oh, can you handle this URL? And how do I connect to this URL? And the driver will be like, we need Postgres. Postgres, and the same tag here. And then whatever the thing, right? Spring, IO. Those are just the database names, I think. And then the driver would create the test container with Postgres, download the Docker image, run it, configure our Spring application to use that database, and then our test should pass. Shall we try it? I think we can try it now. I think this one simple test should pass now. Will it pass? Nobody knows. Such suspense. I hope it passes. It would be very awkward if it doesn't. Right. Does it pass? Yes. No. What not? What? Wait. Did I botch the URL? What? Alpine? Yes, I think it needs the thing, right? Let's try it again. Test containers. Hello? No. Wait, what is that? Post. This is awkward. Do you see the bug? It's supposed to be this simple, right? No, it's the magic JDBC URL. Wait, let's Google that. This is awkward, don't look. It's a string. It's a string. It's the simplest, right? Postgres, whatever, database name. Of course. Of course. So, it's going to be awkward if this doesn't work either. But it's supposed to. I just ran the test before. PostgreSQL. Let me see here. All right. Yes, it was PostgreSQL. Whew. Right. Very good. Thank you. Right. So the other test there, let's see, this one is green now. And we can do, it's actually the actual proper test. So if we wire some things here, so say we say Tox repository, our Tox repository, right? Tox repository. And we're going to auto-wire this, which they don't tell you to do in the actual production, but in test cases, it's fine because you don't test your test, so it's okay to use field injection. It's very good that Oliver is in the next room, so it doesn't hear me doing this. But what we can do, we can do Tox repository exists and then say hola, the same string that we have here. So to verify that not only we create the database, but we actually populate it properly using our whatever flyway integration and or not. So that's what assert that Tox exists is true. Right, I'm going to rerun this thing just because I like it. So our database works fully functional. Now, our healthy endpoint here would not work because besides having database, we need Redis. So while the test runs and we're going to enjoy seeing it's green, which always bothers me as a developer, very much, all the time. You struggle with the things, it doesn't work. It like yells at you error messages. And when you get it green and then when it works, what do? You immediately switch to the next thing. Nonsense. Right, so this one doesn't work now. The context loads, but this one requires Redis. We're going to create Redis here. How do we do Redis? Redis, we're going to do, there is no module or anything for Redis, so we're going to do the generic container, and we're going to say Redis, and we're going to create the new generic container, and we're going to do the Redis Docker image name. And look, there's the IntelliJ IDEA EAP, right? So the newest and greatest. So what I can do now is actually here, which is mind-blowing, right? I can content assist my Docker image names here, which is for test containers. Have you ever seen anything like that? Right? I can just literally, it just goes and checks, verifies which things exist, and if I click on it, it goes to Docker Hub. Just you wait, There is an issue that if I do like Alt-Enter there, it will just allow me to Docker pull it right from my IDE. It's not yet implemented, but I hope it will make the next release, which is great. Perfect. So we have the Redis here. What we can do, we know that Redis is the web application, right? So we're going to create a configuration for that, so that we need to expose this port from within the container. It's going to be a random high-level port on our host side because Testcontainers uses that, so we need to configure our Spring application for that. And for that, I need to use the configuration method called dynamic property source thing, right? So how do you do that? Public static void setup things. And it takes the dynamic properties to registry, and in this method now with the magic URL, or the JUnit integration, when you use the annotations to control the life cycle of your containers, somebody covers the life cycle of your containers, right? But here, nothing knows about when to start this Redis or not. So what we can do now here is we need to do Redis start. Redis start. Let's do it static, so no one complains, right? So we start Redis, and it will bind on like random ports, and now we need to make sure that our Spring application knows where to find this Redis. How we do that? We just do, say, registry, add, and then we do the configuration. Spring Redis host. Can I do localhost here? How many of you think I can do localhost here? I cannot. No, it won't work in all environments. For example, if you do Docker in Docker or like complex setups with remote Docker, localhost is never the answer. What is the answer is asking the actual Redis. Get host. See how convenient it is. My IDE knows what I want because somebody thought about this before. Right, which is great. And also we get first mapped port because we know that we mapped only one port, right? And now our thing will start Redis and also start and configure our Spring application to talk to Redis. So now our health test should pass because before it didn't, because it didn't have Redis, which is magical. And the more the better. So the next test that we're going to run will require Kafka as well. Kafka is even more convoluted, but it's easier because we have, remember we had the Kafka dependency in the POM file. So what I can do, what I have now, I have a Kafka container. So I'm going to go to Kafka, new Kafka container, and it requires the Docker image name here. So I'm going to do Docker image name, parse, and I'm going to do the same string here, Confluent Inc. CP Kafka. Come on, idea. Kafka. Confluent Inc. CP Kafka. Perfect. Maybe this version works. So now we created Kafka. What's great about this is that the library that creates this Kafka integration for test containers, somebody who knows how to run Kafka has thought about things, has thought about configuration for this, and created that for me. There is the Zookeeper thing. There is some configuration with the Bootstrap servers that I need. There is some complex configuration that is required. What is good for me? I don't have to think about that. I don't even need to know how to do that. I just use Kafka. And I can do that with many, many other technologies. I can do, for example, the Postgres, as I did before. Right? I can do Elasticsearch if I just pull the dependency. I can use the Kubernetes module. So I literally can run Kubernetes in my Docker container, and then if I do anything with Kubernetes, I can run, and my application can talk to that as if it was near Kubernetes, which is excellent. And there are a ton of technologies that support it, including the cloud technologies. You can run local stack for AWS. You can run the G-Cloud module with the emulators for the Google Cloud technologies. You can run Azure module if you want to talk to the Cosmos DB, which is absolutely spectacular. All of the technologies never need to know anything about the configuring them. Well, you need to know a little bit about configuring them, but hopefully enough as much as you work with within your application. So now we're going to start both those things. So I'm going to do startables, deep start, Redis, Kafka. This is just like speed up the things. Kafka, join. Right? It will start them in parallel, static. Right? And then I will do the same configuration. I just need the Spring Kafka bootstrap servers. And I do Kafka get bootstrap servers. So, which is very good. I absolutely love this feature where my IDE just helps me do things because of the content assist. Because, well, to be honest, I'm nothing without my tools. So, story of my life. Right, now we can run all the tests, and the whole thing will work because we create the full environment. You can see here in the logs the test containers runs Redis, downloads Kafka, runs our Postgres. The whole thing is managed in Docker. So we are starting something. We run the migrations on the empty schema. It all works normally as it's supposed to. And then it sends, and everything is green. This is how easy you can create the complex environments, either by specific integrations or running anything within the generic container, or by providing abstractions for other people to run this. There are even like harder, there are cool things that you can do on top of that, right? So, for example, there is the ToxiProxy module, which is a sort of chaos engineering tool, where you can say like, oh, put my containers behind the network, and then you access them through the ToxiProxy, and then you can create, oh, please create latency to my requests, or the timeouts, or limit the data, and then you see how your application behaves there. And then this situation is great, and you can run very complex integration tests here. And you can manage the lifecycle of the containers manually, or you can use the annotations here. So since we had the test container, test containers you can manage it with the JUnit Jupyter integration. So you can add the test containers annotation on the class, and then you can add the container annotation on the container. And then the container will be created either, if it's static field, it will be created once per class. If it's an instance field, it will be created and started for every test, sort of like before all and before each. But if you manage it manually, it's just no big deal as well, and it's very, very simple. So now, this is how you can run your integration tests. It's very convenient tool for this. In other languages, I think it's, personally, don't quote me on that, it's a little bit less convenient in Go because there are currently no modules in Go, but maybe there will, well, there are modules in Go as in terms of module, no test containers modules in Go, so there are examples of codes. But we will get there, and eventually all the test containers implementations will be on par with each other and fully proper. Now, I would love to use this simplicity of the setup for running my actual application myself. So I'm going to try that, and I think it's supposed to fail, right? Let me just see. No, it doesn't. Right, so what we worked on before, and we have a prototype for this, which is something that uses the integration with test containers and integrates with Spring, that will look at the class path, look at the classes that you're running, and if it finds that you're using the service dependencies, you use the database driver, and it will be like, okay, you need a database for that driver, but it doesn't find the configuration for that. Then it will use test containers to spin up an instance of the database that you are asking, or like Kafka or others. It will do that, and then we'll configure your application to use those. So if you don't have any configuration, what you can do, let me show you the POM. Where's my POM? POM. It's a project that it's a prototype. So like, unfortunately, I wanted to make it public before, but it didn't happen. So you're gonna look at the code, and then we're gonna see what works, right? So it's a dependency. You add it. Currently, we made it depend on the dev tools. That is a prototype, so there could be questions how to implement it properly. But it's a module. It's a module that you can add. I can show you here in another thing. Open recent auto services, new window. It's a very simple It's a very simple project. It's just like literally a few classes, right? So the whole implementation works on the interface called auto service, which declares the name of the service that you want to run, and it verifies whether it needs to run, and then it just creates the container here in a sort of a very common manner. So it creates a container by the configuration of the image name, and then it starts this, and then it registers with the DevTools not to restart it all the time. So there are a number of cool things there. So for example, it registers itself in the Spring Factories classes, so it works in your projects. But in a nutshell, so you wait, where's my other window? In a nutshell, what happens? You add the dependency, you add the configuration that says, I want to enable this auto services thing for the Postgres, for my Kafka, for my Redis. And then after that, what I can do, I think, I can just run my application. And then it will work. So I don't have anything running, no database here, no trickery. It will think a little bit, and then it will run it using my things in a Docker environment. Right? Let's see. Auto services. Wait, what? So we started, we found out that we need the auto services for all three. How did we find out? Because we request those classes, and also we don't provide the configuration for where to find those things, right? And now we can access our application. We can access our application here. So if I do actuator environment, let me make it larger, somewhere at the very end of this, I think, of this file. This is the whole environment that our Spring application has. And you can see that the Testcontainers Redis injected the properties for this host and the port. So it created the container and injected that in the environment. And the same with Kafka, and the same with database. So now without actually installing those technologies, I get the perfect developer experience. I can just clone the projects, and I can just run them. How amazing is that? And I can use them. Look, I can use them. I can use this project, right? How do you use this? Who remembers how to use this? Generated requests. So I can post requests to my ratings endpoint, right? And then I can go back to my application and just I can use it. So if I do what? Ratings? Yeah, this URL, see? There are 3 ratings of 3. Let's do it 5. Let's say it's a great talk. Very good. And we see it all goes through Kafka. It stores things in the databases. And I have none of that technology here. So this allows me to have very complex setups that are actually isolated within my code of my application, which is perfect because it cannot be, like if it's with the code, it cannot actually desync from the code, right? It's not the separate YAML file that can just become obsolete because something changes. It's always there with the code, so you can use it normally. Any person on your team can use it normally. All you have to do is to have your JDK installed, your Java to run this application, and a Docker environment. And then you can run it, and you can use your applications. So now the world is your oyster. You can just build whatever you want to build with this system. Well, you can't because, well, right? There is no code yet for this auto services thing. There is a prototype, and it will be published. But currently, there is just an issue that you can go and upvote if you will, if you want. Do you like that? Did you like what you saw right there, this thing? Very good. No, in a sense, I'm just, yeah, thank you. Somebody else mostly contributed that, so it's a thing. But yeah, upvote the issue, and we would like to push it out as a prototype as soon as possible, and then hopefully by the next big release, it might be like an actually integrated in the framework, which would be very cool, I think. But don't push it very strong. Everyone has their priorities, so just, yeah. Right, so what's next? What else Testcontainers allows you to do? It allows you to build the setups of any complexity. You can use the containers to extend the lifecycle of your containers beyond your test suites or beyond the lifecycle of your application. You can build complex networks topologies. It provides you with an API for custom weighting strategies because well, it's not enough just to run stuff in a container. You also need to know when the stuff is initialized that you can actually test against that. It's not just you need to run the container with the database. You also need to be sure that now is the time the database is initialized enough that you can run SQL queries against that. So test containers allows you to do that. It allows you to create the images on the fly, access all that. You can even, if you build your native image of your application, you can put it in a Docker container and use it in the same integration tests. So like imagine here where's my demo? No, demo or test. So imagine here this test with the ratings, right? Instead of doing the request specification like that, what I can do, I can create another container with my Dockerized native image application that was pre-built, and just say that my request specification uses not the local server port, but say like native image app get first map port, right? And then it will just hit your native image application with the request using the same test suite, if you will, right? So it's a very flexible approach. What was here first? Local server port. Right. So you can do whatever you wish, and your IDE is there to help you. The test containers, libraries, and modules are there to help you, and you can do that. If you don't have Docker, because, well, recently Docker Desktop underwent some changes, so any compatible Docker environment would work. We recently run the tests, and we run the test containers Java test suite against various Docker environment implementations. And then, it works as long as it works with Docker. There are some issues with Podman, specifically on Windows and Mac OS that we tried, but we are trying to resolve them with the Podman team and working on that. And internally at Atomic Jar, what we're working on is the server backend for test containers-based tests, where the containers are actually running in the cloud while your tests are running locally. So you don't have to run containers locally, which helps very much with many things. For example, here, my M1 Mac, I don't know if it can run Kafka, but I'm running, like all those tests I run using Testcontainers Cloud. So it's a small app that proxies the requests to some sort of a serverless server environment. And you didn't even notice that. I'm pretty sure you didn't notice that, because the latency there is what, like 13 milliseconds. So it's feels like local. Right, so that is not yet public. It's in a private beta. You can go and fill the form if you really, really want to try it. But we'll continue working on that. So all in all, if you want to know and get more resources, there are some URLs. If you want to play with the same sample app, it's available under the Testcontainers/workshop. And then, yeah, sums up the issues, join the community, and let's figure out how to make the user experience of integrated tests better for everyone. Right, thank you very much.